All right. Well, it's great to be here. I want to talk about the fact that I believe all companies are going to become internet companies. So I got into the world of big data, machine learning, data platforms back in the years of Alta Vista. So I'm aging myself there, but grew up, in data in the context of large internet companies. I was at Yahoo for 7.5 years, ultimately became the CTO there. And I left there in 2012 because I came to believe that, what we learned in the world of the internet was going to be directly transferable to pretty much every company in the world. And I wanted to be part of that transition. So what do I mean by saying every company is going to become an internet company? What I do not mean is that, hey, install foosball tables, have free food, and growth will follow. That's not what defines an internet company, especially in this context. I think to begin to understand what I mean by this, kind of that much envied A/B testing. I think the envy is wearing off a little bit, but if you go back a few years, I think many companies were envious of the fact that internet companies could do A/B testing, and they couldn't. And so I think that is at the heart of what it means to be an internet company. But let's dig into that just a little bit more. What is at the heart of A/B testing? I think is the ability to get at and to use data that most large companies to date, haven't had access to. If you look at the sources of data in traditional data warehousing and business intelligence context, it's all about data that comes from inside the company, right? Your ERP system, does spit out a fair bit of digital exhaust that you can collect up. But if you think about it, that ERP system is a completely inward-facing system. And I think what's happening is that increasingly the real world is getting instrumented. We can now measure what's happening outside of our firewalls, outside of our physical walls. We can understand as businesses the direct impact of what we do, in the real world, in real markets, and we can begin to use that data to create feedback loops, i.e. to create A/B testing. And so, as I think about big data and what does it mean, is it the 3 V's, is it machine learning, all of that is great. But to me, the heart of it is that we can instrument the real world and bring real signals back into our business processes and optimize them. And that's what I mean to say, hey, look, we're all going to become internet companies. Another way to look at that is to look at the planning cycles, if you will, or the feedback loops that exist in companies. And if you look at most large companies today, they typically have, at best a quarterly planning cycle that's kind of fed by a yearly planning cycle. That process is very PowerPoint driven. In those PowerPoint decks, there's some degree of data, right? So you could describe this as a somewhat data-driven exercise. But by the time you get to those executive meetings where you're making the quarterly replanning and the rebudgeting, it's very imprecise and very removed from the real world. I think what you have, again, in the context of any companies, for example, an internet company where you can immediately measure what the impact of what you do in the real world, is you now have the ability to create feedback loops that are much more instantaneous. And I think, I'm going to give an example in a minute, but I think that it is really critical to understand that it's not just this kind of instantaneous, real-time feedback loop that I think a lot of people get very excited about as they think about new sources of data and data streaming and so forth, but there's actually nestings of loops where there's intraday cycles, there's intra-week cycles, there's monthly cycles, there's quarterly cycles, there's multiple cycles of feedback that work together, I think, to drive more optimal business outcomes. And so, if we want to think, in its fullest definition, what does it mean to become an internet company, at least in the context of what I'm describing, it's embracing all of these loops is what it means. A little time out here, I want to describe, what I claim to be at that 30 to 50,000 foot level anyways, like the architecture of internet companies, and again, to kind of show how that is directly transferable over to other companies. So, what does an internet company look like? There is at the top of the slide what I call the on-stage experience. The experience you're providing typically to your consumers. And at large internet companies, those measures, that measures in the hundreds of millions of people kind of doing stuff in your applications. And at that hundreds of millions of person scale, those experiences are driven by typically kind of fairly complex content and advertising optimization systems that try to get the right content and the right person at the right time. Critical to those systems is the ability to get that feedback in the form of clicks. That's the user behavior on the right-hand side, but also user-generated content. Has been a little bit of hit and miss in terms of how useful it is as content. Sometimes it is, but a lot of times it isn't. But it does tend to have a lot of signal in terms of understanding how people are reacting to your experiences. So you've got these feedback loops that go into what I've kind of generically called a content supercomputer. This is where Hadoop and big data platforms kind of got birthed, and you create that feedback, that instantaneous feedback cycle right there. But I want to point critically to what's called the backstage here, because I think for internet companies, the importance and the complexity of backstage applications, as I call them, it snuck up on them over decades. And I think one opportunity for non-internet companies to learn from that experience is to upfront understand what those are and why they're important. So what the backstage experience is what people do behind the scenes to both understand and ultimately to influence what's happening on the on-stage experience. In the context of, say, a Yahoo, where I spend a lot of my time, that would include editors at Yahoo. It would include our advertisers who had backstage experiences. We had publishers that we worked with. They wanted to understand what was going on. They wanted to influence what was going on. Developers are another one. And so, being able to go to consoles, to look at metrics, to understand, hey, what's happening, on stage, and how, and having knobs ultimately that you can twist and turn to influence, what's happening is critical infrastructure to creating those closed loops that I talked about, especially those closed loops that are not that automated, man out of the middle kind of exercise where you've got that intraday, intra-week rhythm of people looking at stuff and trying to redirect what's happening through, twisting knobs. A lot of so-called analytics, by the way, live back there, right? That's where you got all of your querying and visualization and so forth. Now, when the onstage kind of becomes buildings and printers and trucks, my claim is that this architecture really doesn't change. And a lot of what we learned from an architecture and system design perspective will transfer fairly directly. And in particular, I think the importance of those backstage experiences will continue to be critical. So what I want to do is dig a little bit deeper into, if you might call it the how of using data to drive optimization. There's this data insight action kind of aphorism that's been around for decades, and quite honestly, I really don't like that because it leads to the PowerPoint, right? The data is a bunch of raw data. The insights are some Tableau graphs. The action is PowerPoint slides, in executive suites, and it I think is not true to being data driven as it claims to be. So I've got a reformulation of this, which is to say, hey, form a hypothesis. And the critical thing, and this is what I think is critical to A/B testing, is that the hypothesis includes a proposed action. I want to change things in this way. And by changing things in this way, I predict the following outcome. This really turns it into true science. With the hypothesis, you can then create an experiment. And then as your experiment proves out the hypothesis, you then can move ahead and kind of implement, the action, if you will, that was embedded in your hypothesis. So let's kind of walk through this in a bit more detail. The steps are formulate a hypothesis, and as I indicated and stressed, this should imply an action, right? I want to change the size of my button, or change the delivery schedule of my trucks. But the key thing is you don't stop here. Now, a lot of times to get to a hypothesis, you do go through something that does look like the data insight action kind of waterfall, right? And so that is useful as you try to kind of formulate a hypothesis. The problem with that is then people stop. They say, hey, my hypothesis is reality. Now let's spend $10 million to implement a new program. Obviously, that's a mistake. So the next step then is to run experiments. And I think the critical insight here is that as you get more sophisticated at running experiments, what you do is you build these ladders of experiments where at the bottom rungs of the ladder, the experiments are cheap, but the outcomes are a little bit more questionable. As you get to the top of the ladder, the experiments are much more expensive to run, but they're much more definitive. And the interesting thing is if you think about A/B testing, that lives much more at the top of the ladder than at the bottom. to actually get to the point where you're doing A/B testing in production at a large company like Yahoo or Facebook, you have to implement the code. There's typically a lot of pre-screening that you have to do. The buckets, so to speak, that people run these tests in are highly contended, so there's actually opportunity cost for running an A/B test. It's a fairly expensive experiment to make. If you think about something I'm familiar with, which is search relevance, we had huge numbers of experiments that we could run based on back data, right, to kind of test ideas about driving improvements to relevance, that we would run well before we tried to A/B test any change we made to the relevance algorithm. So building that ladder, I think, is critical, among other things, to really enable kind of bottom-up, action, the ability to have, somebody who's not necessarily empowered by virtue of their place in the hierarchy, to prove that they have a good idea without spending a lot of money. What gets in the way of this, by the way, is access to data. Probably, I don't have to stress this here, but a lot of times the data that you need to either formulate the hypothesis or run the experiment is locked up in some system that has a whole bunch of policies around it that don't make any sense, but they live there, and you got to fight that fight. Another key thing is moving from experiments to production can be hazardous. In the old days of search, a lot of times we'd have folks who would know how to tweak machine learning algorithms, but they didn't know how to code, right? And so they'd come up with a change to the relevance algorithm that showed in some forms of experiments that improved relevance, but then that was thrown over the wall to developers who had no idea what it really meant. They would implement it in C or something else, and then the improvement was lost. So as you build the experimental apparatus, making it true to life is pretty critical. What I'm going to do here now is to run through an example which we did at Yahoo many years ago, and I kind of mothballed this example, but recently with the fake news, Facebook issues that have been going on, it feels suddenly relevant again. So you might find it interesting. So the key question is, we had this thing here where we would put news articles, right, and that was basically clickbait. How do we get people to click on those articles? Because not only would that drive more experience or engagement for the users, but actually it would drive money to us because there's often ads on the other side of those clicks. And a long time ago, that was manually programmed by editors, right? So every story, every position was a manual decision by a news editor, basically, to decide what went there. And so the search people at Yahoo said, well, that's the stupidest thing in the world. Why would we ever put people there? We can do it much better with algorithms. We can get rid of the people, right? And that kind of sparked this enormous man versus machine debate that went on for 2 years, and that itself is an interesting dynamic of these exercises. So the hypothesis was automation can do better than editors. We can get rid of the editors, right? So that was a hypothesis. And so what did we do? We kind of went ahead and formulated an experiment. And it turns out that we had tons and tons and tons of back data, right, in terms of what did we show, who clicked on it, perfect for building click prediction models. And it turned out that for whatever reason, we couldn't learn this problem, right? We couldn't generalize, as they say, the clicks. Maybe we didn't bring enough data into it. Who knows what? But the search guys failed. But the interesting thing is that we looked at something else, which is reinforcement learning, right? So instead of trying to predict what people would like, let's run experiments in real time and see what people click on, and that turned out to generate very good click-through rates. Where this ultimately went then was kind of a system that brought man and machine together, where the editors would propose anywhere from 20 to 100 and over time 200 different stories that they think might be good. And the reinforcement learning would then figure out which ones were good, but more importantly, which ones were good for which audience, which turned out to be very powerful and not something we could do when it was all programmed manually. So this is an example of that kind of hypothesis experiment, implementation. And by the time we got to the one on the right, the good news is it was so data-driven that there wasn't any hesitation to go into production with it. And again, the backstage experiences are critical. This is kind of intraday click-through rates. But this one I kind of like. Basically, this we fed to the editors, which told them demographic on top, story along the left, how was it clicking? And so I talked about these backstage applications which allow humans to interact with sometimes fairly sophisticated algorithms. This is a small example of one. I'm going to throw that up, but since I want to keep you on time, you guys can read. You can ask questions about these if you want, but why don't I stop here and see if there's any questions.
Hey, Ed. Hello? All right. It's working now? Oh, no feedback. All right. Thank you for telling me that. So I would have you alluded to some of this, but could you maybe tell us more about Altiscale, what you guys built, and the story of the company and all the things?
Yeah. Well, so my role at AltaVista and later on at Yahoo was to build more of the systems infrastructure than to do the machine learning. I knew enough to be dangerous as far as, say, relevance science was concerned, but my job was to take the sophisticated algorithms and implement them at scale, and then to build the data infrastructure that the data scientists use to actually run these experiments that we talked about. So I did that, again at AltaVista, later on at Yahoo, and Hadoop at Yahoo became kind of our standard infrastructure, and we made a large investment in that. Through the spin out of Hortonworks, that I was involved in as the CTO at the time, I kind of got a glimpse at how larger non-internet companies were struggling with the adoption of Hadoop. Their clusters were kind of subscale. The people operating them were kind of operating them and 10 other things at the same time. They'd have 2 people, not 100, using it. So if anybody got stuck, they'd immediately have to go search the web, Stack Overflow, to figure out what these stack traces mean. And it was hugely unproductive. So, at Altiscale, we said, hey, let's deliver Hadoop as a service in the way it's experienced at a Facebook or a Yahoo or a Twitter, where it's just there, it runs. It's fully accessorized in terms of all the tools that people want to use. And we had what we call our help desk, right? So if people got a stack trace, they could just say, hey, what is this? And we'd say, yep, out of memory, here's how you fix it. And save them sometimes up to a day. So we wanted to deliver as a service the type of big data experience, again, that people had in these large internet companies, so they could move on and live this glorious future that I talked about. I will say what I learned along the way is that while that data infrastructure certainly is a bit of a blocker, right, to transforming your business, actually changing business processes is much harder, right? That's a social engineering exercise. It's not a technical engineering exercise, and those take a much longer time. And so we were required by SAP a few months ago, and for me that was a big part of the thesis there, that SAP has a lot more experience and a lot more capability to help drive into customers' changes at the business process level than we ever could at Altiscale.
And do you think eventually all big data infrastructure goes to the cloud and is delivered as a service, or did you find a fair amount of reluctance of large companies to put that data in the cloud?
Well, both. I mean, I think there is, and there continues to be, a lot of resistance to putting infrastructure in the cloud. I think for applications, that's kind of, that ship has sailed, but for data infrastructure, for what we do, it's still a huge battle. My personal view is, 10 years from now, where it's going is clear, and I think when I started the company, companies like Bloomberg, for example, would say, no way, no how, we'll never do anything like big data in the cloud. We might do Salesforce in the cloud, but that attitude has changed, and I think by and large people understand that all IT infrastructure is going to end up in the cloud. But especially in these what they call highly regulated industries like financial services, there's, it's the social engineering, right? The regulators have to catch up and say, okay, you can do it that way, right? And the insurance companies and all these contracts that people have in terms of, hey, you can have my data, but you have to put it on a PC in this locked, vault, right? There's a lot of non-technical issues that are going to make that, a long and painful journey. But I think where people are at this point, I think it's not controversial in terms of where it ends.
Great. Do we have questions?
There's one over there.
Do we have anyone with a mic? Okay. I'm the person then.
Hey.
Hey.
Hey, Raymie, I really enjoyed your talk. One of the things that you brought up really early on were feedback loops. How you iteratively make the feedback loop tighter and tighter. And you described that in context of building an internet company. And companies are made of people. You brought it a little bit back into that thread when you mentioned feedback loops with the non-technical pieces of how to operate stacks, for example. And it's a really interesting example of how do you actually propagate knowledge. What feedback loops work for making better decisions? Like how do you use like the example that you gave and similar examples? Like what works?
Well, I'm having a little trouble processing the question, but maybe I can give a different example, which comes from my background that might indicate how these things work together. So one thing that's always been fascinating to me is CPA advertising, right? Cost per acquisition advertising, and because the feedback loops there are very, very, very intricate and intertwined. So most CPA companies do have some type of automated click prediction models that they use to kind of buy inventory in real time. But a lot of times they have a portfolio of ads that they're running, and a lot of times they'll say, hey, this, the return on this campaign is dropping. Let's give it to a person who then hand optimizes it. And these people are kind of interesting creatures because on the one hand, they can drive Tableau and they can understand numbers, but the other hand, they also understand, hey, red clicks better than blue, or red clicked well yesterday, but let me try blue today because something's changed, right? They have a certain kind of intuition in terms of, what drives good performance that they can use to then kind of go from a local optimum to a better optimum. And that's what I call intraday. On an intra-week basis, you got people who are looking at that portfolio and putting campaigns in, taking them out, and then there's buying inventory, which happens more on an intra-monthly basis. And all of this is kind of data driven. So I think to me, that's kind of like the height of these nested feedback loops, working together. As you go outside of internet companies, and you don't see that yet, but I think it's coming. It is an act of creativity, however, to say, hey, I run a trucking company. How can I create those nested feedback loops? Like I can't tell you. That's where the business innovation has to come from.
Great. Time for one more.
That guy's still waiting.
There. Yes.
You have listed as obstacles diversity of talent and tech transfer. Can you elaborate on those?
Yeah, okay. Try to make a short version. So that diversity of talent, so again, in sponsored search, I saw this. It was fascinating, right? We had economists, we had click prediction folks, we had the stochastic optimization guys that would kind of put everything together and say, hey, here's how you balance different interests. Click predictions, machine learning. The fascinating thing is every one of those problems, it's optimization. They all do optimization. You get those three disciplines in a room, they cannot talk to each other. They all do the same math. But the way an economist looks at the world, the way a machine learning person looks at the world, the way the other one looks at they all look at it very differently. And so, if you want to build a very sophisticated model that blends these different fields, it's complicated to get those different disciplines to talk to each other and to come up with an overall solution. So that's what I meant by diversity of talent. Tech transfer, maybe it's a bit specific to internet companies, but what happens is you'll build an ad server, you'll build an optimization, a search engine, right? You'll build some news feed, algorithm that works great, and you totally understand the business characteristics of this. You totally understand how to kind of drive it on a day-to-day basis, but it hits a local maximum. And then the question is, and you've got some team that thinks it knows how to drive to a higher local maximum. The problem is on day one, the new system always starts below the local maximum of the old system. And so the folks with the better algorithm, so to speak, or the better mousetrap can never get the investment to go into production because the guys who are protecting the old system come in and say, well, look, you know, if we shift to their system, we're going to lose 25% of our revenue. We could never do that. Go away, right? You know, and there is a seasoning that happens to these systems that does. You just got to put it in production. You got to learn the hard lessons. And so, tech transfer here is not the traditional. Hey, you know, I'm in research and I have something and I want the product guys to sell it. It's a little bit deeper than that. Because there's real money at stake here. You can't throw away 25% of your revenue, and yet, and so that's another obstacle that people face.
All right. On that note, thank you very much.
Sure.
I appreciate it.